Hello everyone and welcome. I am Abby Sophia, also known as the Moonlit Empress, and this is the next A Little Witchery devlog documenting the development of a Zelda-inspired action-adventure game where instead of using a sword and a shield, you use a constructive magic-based system in order to cast your spells. The past 2 weeks have been spent developing the first iteration of a test dungeon. The dungeons in this game provide the vast majority of the gameplay and are labyrinthine-style structures that offer a range of exploration, puzzling, and of course, combat. Such a task required pulling together all the different elements of A Little Witchery that have been developed so far. This episode will cover the creation of the dungeon from the initial design phase into the final level blockout. We'll also be covering the development of the objects, chest doors, enemies, and mechanisms that the player will be interacting with throughout the level. Without further ado, let's jump right in. Before we get into the meat of this week's episode, I'd like to show some changes I've made to the camera and spells. Previously, the camera was close and over the shoulder of the player character Cassie. This created a more visceral connection to Cassie, which I liked, but it also prioritized action more heavily than intended. With platforming and dodging more important in combat than aiming, I decided to pull the camera back so that the player has a better sense of the playing field, giving movement just as much focus as the combat. Of course, an issue that arose was losing the one-to-one connection of casting spells that I believe is very important to the overall feel of the game. To remedy this, I created a second arcane circle and Cassie model that always sticks on the camera and mirrors Cassie's actions to retain the best of both worlds. I also shifted around the spells a bit. The Fire Blast ability that stunned enemies was nearly never used, and when its rare usage case appeared of enemies getting too close and surprising the player, it took too long to cast and was simpler to just dash away. The camera change meant that enemies' ability to sneak up on the player was further reduced, and that was the last nail in the coffin for the usefulness of this spell. Second, the Rock Wall ability, while extremely useful, seems so much so that it could be used as a crutch for the player. I also struggled to design interactions between the wall and the environment. Having a dual combat exploration purpose is necessary for all the spirit spells, as these will be the quickest to cast and the only spells every player will have access to throughout the entire game. These spells will probably be back as a part of their elemental suite later on, but they're simply better spells for the player to have in their main toolbox. I replaced the wall with a boulder that can be pushed by the wave. I like the synergy between the spells, plus the boulder can be placed on pressure switches and even used as a small shield in a pinch, retaining some of the wall's basic functionality. The Fire Blast has also been replaced by a Fireball, previously a Spirit Ball, and the new wind spell is the dash mechanic, which is no longer a basic traversal ability bound to a key press. I'm not sure how the dash as a spell will play out, but I think it's an interesting enough concept to at least try. Finally, a commenter on one of my previous videos suggested that after casting a spell it should stay queued and be recast with a single button press. I thought this was a good idea and worked it into the game. If you have any ideas for A Little Witchery, leave them in the comments below. I read them all and you'll never know what'll strike as a good idea. The idea of dungeons are heavily inspired by the Zeldas, and I want to try my hand at creating some engaging and exciting locales for Cassie to explore. Since this is the first iteration of a dungeon for this project, I had some very clear goals of what I wanted it to accomplish, but I also made sure to keep those goals open and flexible for the inevitable adjustments that must be made to accommodate a very different core playstyle. While doing conceptual level design, I like to use an application called SketchUp. While primarily an architectural software, it allows me to draw out my core concepts for the dungeon in a quick and highly iterative way before bringing this rough draft into Unreal to block out the level. The first intention of the dungeon was to practice designing an increasing level of complexity throughout. It's important to ease your players into new concepts or game mechanics. If you throw too many things at once, the player will get frustrated and say the game's too hard. If you delay the introduction of new mechanics too long, they'll get bored and go play something more exciting. You want them to stay balanced between those two feelings in what is called the flow state. The first act is simple and straightforward in order to introduce the core design. The second introduces the idea of branching and overlapping paths. The third provides the player with a challenge to master those now familiar concepts. By creating a vertically oriented dungeon, it allowed me to design each floor, 1, 2, and 3, as discrete steps on that complexity curve. Second, I wanted there to be a large, tall, central chamber. This provides a place for the player to orient themselves if they get lost. It also works as an intuitive area for the player to rest and respawn if they die. Additionally, by adding an elevator, the only way to ascend the dungeon's floors, it gives the player a clear goal of returning to this room and raising the elevator in order to progress. The third and final intention of the dungeon was to make all of the obstacles that Cassie faces to play off the main 4 spells the player has access to. This ensures that the player should have a base level familiarity to all the obstacles, nothing out of left field that will make them feel stuck. But the intention isn't so much for the player's benefit as my own, being a designer in the early stages of development. This forces me to look at each spell under the microscope and really see how useful and versatile it is as a core spell for the player. And if I can't find enough ways to make a spell useful, it should be swapped for something else. I brainstormed about 4 to 5 different ideas for each spell, and after choosing 1 to 2, I moved back to Unreal to start coding. When designing the code for these objects, I knew it would be important for them to be quickly modified, and that when I add new objects, they can be rapidly added while I'm iterating on all the possibilities. In order to do this, I first broke all the obstacles down into its constituent components to identify any common patterns I could take advantage of to create a better workflow. What I noticed is that each obstacle has 2 main components. You have the activators. These are actors that the player directly interacts with and turns on and off using spells. For example, the pressure switch, spinner, and torch all constitute as activators because the player directly interacts with them, but they don't do anything of their own accord. The second class of components are the mechanisms. These actors are the actual drivers of the outcome of the action and represent the results of the player's actions. For example, bar locks, platform risers, and chest spawners all classify as mechanisms because they perform an action and the player only interacts with them indirectly through the activators. Now, in order to take advantage of my newfound understanding, I used a common programming trick called inheritance to share some basic functionality between all the actors of the same class. For instance, if I want to add some new functionality to all the mechanism actors, I only have to code that process once in a base class and it's immediately shared between all the actors. How this works is that the actors exist within a hierarchy. At the top of the hierarchy is the master or parent class that holds all the most basic and versatile functionality. When you create a child of this blueprint, it exists lower on the hierarchy and inherits all the functionality from the class above it. And then you can add some additional unique functionality as well. Take the chest spawner, for example. It inherits the ability to communicate with activators from the base class, and you add the unique functionality of creating a chest when its activators tell it to turn on. All the baseline and backend functionality is already present and working. This makes creating new actors or improving the functionality of the class as a whole easier and faster. The shared backend functionality allows the communication between activators and mechanisms to be foolproof. Once all the actors have been brought into a scene, all that must be done is to select the activators attached to a certain mechanism, and those activators receive a command to tell who to communicate with, allowing new rooms and obstacles to be created and iterated on extremely quickly and easily. Now with everything ready, it's time to start blocking out the level. A level blockout is a version of the level where only the necessary gameplay components are included. This allows the levels to be quickly changed and altered depending on the gameplay's needs before the art and visual design is added. Once the environment is added, it becomes much more difficult and time-consuming to make any adjustments, and so is generally avoided. Any iterations need to happen before the art is added, in the level blockout phase. Thankfully, because I've already outlined the level and created the interactive components, everything is just drag and drop until it's all in place. And voila, the first playable dungeon is created and in the game. Now, this is really a test dungeon to help me understand the direction the gameplay is heading and what to adjust. Through this process, some very insightful things were revealed to me. First, the only enemy that really works in these types of rooms is the mermaid enemy I made previously, so expect some new enemies to be added down the line. I also realized this dungeon is entirely missing any optional exploration or secrets, so I'll need to design some system that encourages players to go out of their way and explore the secrets of every room they enter. On the positive, this experience has reinforced that the core concept of this game is fun and engaging, and is something that deserves to see itself completed and fully released. The past 2 weeks have been some of the most I've learned and represent the single largest step forward I've taken so far in A Little Witchery's development. I reinforced and refreshed my level and dungeon design. For the first time, I took full advantage of the inheritance functionality within Unreal's blueprints. I also gained valuable insights into how the game is coming together overall, which allowed me to see any systemic holes or weak links, and also reported that at its core, this game is definitely worth playing. Stay tuned, because next week I'll be creating an all-new potion brewing system. The idea being that if you hide potion ingredients around the dungeons and levels, this will incentivize the player to explore. If you'd like to stay updated on the development of A Little Witchery and Cassie's story, consider subscribing, and you'll receive a weekly devlog containing all the new and exciting things that I've added. Or you can follow me on Twitter and Instagram if you prefer to receive updates that way. Thank you so much to everyone who's followed my development journey so far, and I'll see you next week. Stay magical.